Okay, we are continuing with solutions from this Desmos activity. Okay, so in this problem, we have a log and then binomial expansion on the inside. So we are going to use the log rule, which is the chain rule. And then on the inside function, we're going to use the chain rule again and then use the power rule. So let's get started. So the derivative of the outermost function, which is log base 4, is... so I have natural log of 4 times what was originally in the function, inside the log function, so 3x squared plus 3 to the 4th. And then we need to take the derivative of what was inside, so this is the first time we're going to use a chain rule. So we bring the 4 down and multiply by 3x squared plus 3. So we leave that inner function alone. Reduce the exponent by 1. And then we need to multiply by the derivative of the that inside function, so you get 6x. So shockingly, none of these are solutions in the multiple choice options, so we're going to do a little simplifying. First, we can try to eliminate answer choices that we know can't be right at this point. So there's a natural log of 4 in the denominator of this, which is correct. So we can eliminate any answer choice that does not involve a natural log of 4. So those two are gone. Looking at this, if I were doing this problem and I wasn't sure how to simplify this, I would automatically sort of be gravitating towards C just because it looks a little bit more reasonable. But, let's see what happens. Okay, so there's a 3x squared plus 3 cubed in the numerator and a 3x squared plus 3 to the 4th in the denominator, so those are going to cancel. So at this point we have 24x, so that's the 6x times the 4 up here, over natural log of 4 times 3x squared plus 3. A 3 can factor out of the 3x squared plus 3. And, well, we could, but the answer choice is already here. It's C. This is exactly what C was. This would also have been equivalent to 8x over natural log of 4 times x squared plus 1. If that had showed up anywhere. Oh, interesting. I should have done that. Oh, well. Regrets. Okay, so we have a product here, so we're going to use the product rule. When we take the derivative of the first term, we're going to have to use the chain rule, because the derivative rule for exponents is just the chain rule. And then we're going to have to do the same thing when we take the derivative of the second term. So let's get to deriving. Okay, so y prime. So the derivative of the first term is going to be natural log of 10. Times the original function, 10 to the x over 3, and then times the derivative of the exponent. It's 1/3, so that's the chain rule piece. And then continuing with the product rule, the derivative of the first term is going to be multiplied by the second term. My mail is here. All right. So then continuing with the product rule, so now we've done derivative of the first term times the second. Now we need to do first function times derivative of the second. Derivative of tangent is secant squared, the original function. And then times the derivative of the inside of the function. So now we're taking the derivative of e to the 4x. The derivative of e to a function is just e to the original function times the derivative of the exponent. So that's just going to be 4. Okay, so we need to do a little bit of simplifying. It looks like maybe we might need to use a calculator. Let's see. So if I clean this up a little bit, I'm going to get natural log of 10 over 3 times 10 to the x over 3 times tan of e to the 4x plus 4 times 10 to the x over 3 times secant squared of e to the 4x times e to the 4x. Okay, so are these any of the answer choices? So B is looking promising because I have a natural log of 10 over 3, like right here. But I have planted a very tempting algebra mistake here. Here, when you have 4 times 10 to the x over 3, you cannot multiply that 4 times the 10. In the order of operations, you have to do the exponent, x over 3, before you multiply. So anything that has a 40 in it is a red herring and should be eliminated. So let's eliminate with a vengeance. No. And I see the same mistake here, so that option is out. So let's take a look and see which other answers are here. Oh, okay, so I'm looking at A, and the over 3 has disappeared, right? So this guy, the over 3, is missing from answer choice A, so that makes me think it might not be a good choice. But then when I look at D, I'm like, wait a minute, that looks the least like what I have so far. But I will show you why it is correct. Okay, so natural log of 10 over 3 is just a number. And when I put that in my calculator, I do natural log of 10, divide by 3. I do, in fact, get 0.7675. And then I've got 10 to the x over 3, tan of e to the 4x, plus 4 times 10 to the x over 3 times secant squared, yada, yada, yada. All this stuff is still the same. Now, one thing to notice is that there is a 10 to the x over 3 in both terms. Right here, right here. So I'm going to factor that out, and that's going to bring us to the solution. So 10 to the x over 3. And then what's left behind in parentheses is the 0.7675 tan e to the 4x. And then in the second term, I'm going to have 4 e to the 4x times secant squared e to the 4x. And that is answer choice D. So that's how we get D. Okay, so I think we're on the last one now. Okay, so here we have a exponential. The derivative rule for exponentials is just the chain rule, so we're going to do a chain rule. And then in the exponent, we have a quotient, so we're going to have to use the quotient to take the derivative of that. Okay, so here we go. N prime of D. So it's going to be natural log of 3 times the original function, 3 to the x squared plus 5x over x to the 4th, times the derivative of the exponent. So here I'm going to have to use the quotient rule. Okay, so so the function of the denominator times the derivative of the numerator minus high, so the function in the numerator, times d low, all over low, so that's going to be x to the 8th. Because, I don't know, I guess maybe we did bad things in a previous lifetime, this Beautiful. Derivative is not any of the answer choices, so we need to do some simplifying. All right, so let's see what we can do with this thing. All right, nothing I can do with natural log of 3. I have 3 to the x squared plus 5x over x to the 4th. Not much I can do with that right now. But there's a lot I can do inside these brackets. You get 2x to the 5th plus 5x to the 4th. And then minus 4x to the 5th. I distributed the negative sign and the 4x cubed to the x squared, all in the same go there. Then we get minus 20x to the 4th, same deal, all over x to the 8th. Okay. If I continue to simplify inside the brackets here, so sorry, I'm not going to rewrite everything. It's very bad math form. I'm going to get negative 2x to the 5th. Right, this 2x to the 5th and this minus 4x to the 5th make negative 2x to the 5th. Then we get minus 15x to the 4th. All right, plus 5x to the 4th minus 20x to the 4th, all over x to the 8th. All right, continuing to simplify that. So I'm not, this still doesn't appear in any of the answer choices. So continuing to simplify this in the brackets, let's choose purple, I guess. In the numerator, I can factor out a negative x to the 4th. And then what's going to be left behind is a 2x plus 15 all over x to the 8th. Now this x to the 4th is going to cancel into here, and I have negative 2x plus 15 over x to the 4th. All right, so we're getting closer. So right now I'm looking at C and D because I see they've got a 2x plus 15 over x to the 4th. The issue at the moment is this negative sign. I don't see a negative sign in either of these. However, I do notice that they have a natural log of 1/3 instead of a natural log of 3, so maybe it has something to do with that. And aha, it does. So at this point, our derivative is in prime d equals negative, so I'm bringing the negative from here out to the very front, natural log of 3 times 3 to the x squared plus 5 over x to the 4th. And then our simplified derivative there was 2x plus 15 over x to the 4th. So this is almost exactly the answer choice C, except that the answer choice C has natural log of 3 and not natural log of 1/3. So here's the tricky part here, is that using log properties, this negative sign, I can bring it up into the exponent. So this is the same thing as natural log of 3 to the negative 1 times 3 to the x squared plus 5 over x to the 4th times 2x plus 15 over x to the 4th. And that's where the natural log of 1/3 comes from. So that was the tricky, this was a pretty algebraically difficult problem in general, but that was definitely the part that a lot of people might not catch. So that's why the answer to this problem is, in fact, C. And I think that's the last problem. So if you have any questions, just let me know in class or shoot me an email or whatever. And I will talk to you all soon. Thanks. Bye.